Hello again, and welcome to the 7th instalment of Differentiation for Year 13 Edexcel A-Level Maths. So we're 6 lessons deep into this massive chapter of differentiation. We're now going to have a look at chapter 9.7, which is parametric differentiation. I would highly recommend that you look at chapter 8 before doing so, which talks about parametric equations generally speaking. So you need to know chapter 8 before really tackling chapter 9. So depending on how you do your scheme of work, it is a prerequisite to know what parametric equations are. So I'm going to assume you've done chapter 8 first, okay? So before we begin properly, of course, let's get warmed up with 3 different questions to attempt. So here they are. So first of all, question 1 is about parametric equations to make sure you're brushed up on what they are and how they work. Question 2 is about the discriminant, that's a hint. Question 3 is partial fractions. So I'll give you a bit of a clue there for all these 3. Press pause now is what I'd say. Try these questions on your own, then press play to see if your solutions match up to mine. Okay, so assuming that you've done that and have paused the video and are ready to see the solutions, let's now see the solutions. So warm-up question 1, how do we do that one? So we're told here, a curve has parametric equations x equals 6t plus 1, and also we've got that y equals 5 minus 4 over 3t, where t isn't allowed to be 0. We need to show that the Cartesian equation of a curve can be written like this, where a and b are constants to be found. What we need to do is eliminate t, so we've just got it all in terms of x's and y's. So I'm suggesting we look at this equation in terms of x and make t the subject. So if we subtract 1 from both sides and then divide through by 6, we can see that t must be x minus 1 all over 6. And so what we can do now is then actually substitute in this expression 4t into the equation for y. So what we have here for y is that y equals 5 minus 4 over 3t. But we know what t is now. T is this thing here. So if we now substitute this in to the equation for y, we've got that y equals 5 minus 4 all divided by 3t, where t is x minus 1 over 6. So if I just write this as a more simplified fraction, I've got y equals 5 minus 4, and then 3 divided by 6 is the same as a half, so you're going to write this as a half x minus 1. And then I can simplify this fraction. I don't really like having a fraction within a fraction, it just looks quite complicated. So if I multiply both top and bottom of this fraction by 2, I can simplify this expression for y. So in other words, y, 5 stays as 5, and then I simplify this fraction by doubling the numerator, 4 goes to 8, and then the denominator, if I double the half, I'll just get a whole lot of x minus 1. Now what we can do to both sides is to multiply through by x minus 1, so we can get it into this form where y is the subject. So if we multiply through both sides by x minus 1, as I say, we next have that y, brackets x minus 1, equals 5 lots of x minus 1, and then this fraction multiplied by x minus 1, this x minus 1 on the denominator cancels with what I'm multiplying it by, so I just have minus 8. So expand this out, I get y lots of x minus 1 equals 5x minus 5 minus 8. Simplifying a bit more, 5x I can leave as 5x, minus 5 minus another 8 is minus 13. Then as a final step, if I now divide through everything by x minus 1, then we've got y as a subject, and it's in the correct form we want. So now we have, therefore, y, oops, I'll get the black pen, y equals 5x minus 13, all of that divided through by x minus 1. So in this case, our a is 5 and b is negative 13. So that's question 1 done. Let's now have a look at question number 2. So here we have f of x is x squared minus, in brackets, k plus 8 lots of x, plus, in brackets, 8k plus 1. Given that the equation f of x equals 0 has 2 equal roots, find the possible values of k. The clue for this question is it says 2 equal roots. So when it says about 2 equal roots, that's a big clue, which means they're going to be talking about the discriminant. So if we've got 2 equal roots, we can interpret this as the discriminant of this quadratic is equal to 0. And if you want to be lazy and want a symbol for the discriminant, it's actually given by this delta symbol. And if we have 2 equal roots, the discriminant is equal to 0. If it's 2 distinct roots, discriminant is greater than 0. No real roots, just remember discriminant is less than 0. So what is this discriminant? Well, discriminant, we need to remember, is b squared minus 4ac. So that equals 0. Now, if you're particularly rusty or haven't done some work for a while or whatever reason, you might be thinking, what's a, b, and c? Well, a is the coefficient of the x squared. There's only one x squared, so the invisible coefficient here is 1. The b term is the coefficient, the number or value in front of the x. So our b is minus k plus 8 in brackets. Finally, the c is the constant term at the end. Our c is just 8k plus 1. So if we substitute these values in now, b squared is going to be minus k minus 8 all squared. Then minus 4 times a, which is 1, times c, which is 8k plus 1, equals 0. So now we just need to neaten this up, expand out, and solve. So minus k minus 8 all squared. First of all, we square the first thing. Minus k multiplied by itself gives us k squared. Remember, minus times a minus gives us a plus. The middle term, we multiply the minus k and the minus 8 together. Minus k times minus 8 gives us positive 8k. We then double that to give us plus 16k. Finally, square the last thing. Minus 8 multiplied by minus 8 gives plus 64. Then this is minus 4 times 8k, which is minus 32k. Then this minus 4 times by 1 is just minus 4. So now, neating it up, we have k squared. 16k minus 32k leaves us with 16k in total. And then 64 minus 4 gives us plus 60, which is 0. At this stage, you might want to class whiz it to get the solutions directly. What you could do, though, is actually factorise this. I need two numbers that multiply to 60 and add to minus 16. With a bit of thinking, you should hopefully see that those numbers are minus 6 and minus 10. So k minus 6, k minus 10 equals 0. And therefore, the values of k that make each bracket equal to 0 would be, first of all, k equals 6 for the first bracket, or for the second bracket, k equals 10. So either k equals 6 or k equals 10. Those are the two possible values of k which we needed to find, which we have now found. Therefore, we've done question 2. Question 3. We've got a partial fractions question here, and we need to find the values of the constants a, b, and c. So what we do here is we multiply the whole thing through by this denominator, x squared, x plus 1. We multiply the whole thing through by that. And then what we have next is just this numerator, which is 7x squared. Whoops, get the red pen again. So we've got 7x squared plus 2x minus 2 equals a. Now, if I multiply a over x by x squared, dividing by x, multiplying by x squared leaves me with a positive x overall. I've got this bracket x plus 1. If I multiply this b over x squared by x squared brackets x plus 1, the x squared on the bottom by the x squared and multiplying by will cancel, so I'm just going to be left with b lots of x plus 1. And then finally, c divided by x plus 1 multiplied by x plus 1, the x plus 1 terms will cancel, so we're just going to have c multiplied by x squared. We then just carefully pick values of x to eliminate a, b, or c, so we can focus in on one of the other ones and evaluate a, b, or c individually. So it's up to you which way you want to do it. What I would personally say is, though, let's go for x being equal to 0. If we pick x equal to 0, then the a stuff and the c stuff will vanish. So if I just set, first of all, if x equals 0, then what we have, 7 lots of 0 squared is nothing, plus 2 lots of 0 is, well, nothing. So we're just going to have minus 2. So minus 2, this term here becomes 0, because a times 0 is 0. Then we have here b multiplied by 0 plus 1, which is b. And then c times 0 squared is nothing. So in other words, b equals minus 2. So we've got one of them now. B is minus 2. What we can do next is think of another value of x to pick, which will eliminate some of these terms in terms of a, b, or c. Now, if I were to pick x being minus 1, that would eliminate a and b for me, so I can then work out c. So let's now try x equals minus 1. When x is minus 1, this becomes 7 multiplied by minus 1 times minus 1. That becomes 7 plus 2 times minus 1, which is minus 2. 7 take away 2 is 5. Take away another 2 is 3. And over here, if I substitute x being minus 1, this bracket is equal to 0, so I have no terms involving a, no terms involving b either, for the same reason. I will have then c multiplied by minus 1 multiplied by minus 1, which is just a positive c. So therefore, in other words, c is equal to 3. Finally, we just need to work out a. So to be honest now, for a, we can pick whatever we'd like. So I'm going to go for, I think I'll pick, to be honest, let's go for x being equal to 1 now. So if x is equal to, say, 1, I could pick anything really, because I know I know b and c, so I can work out a using any number of different combinations. But if x is 1, the left-hand side becomes 7 plus 2 minus 2, which is just 7. Over here, a times 1 is just 1a. 1a times 1 plus 1, which is 2, gives us 2a. So I've got 7 equals 2a. Now b, brackets 1 plus 1, is the same as 2b, but b is minus 2. So minus 2 multiplied by 1 plus 1, which is 2, gives us minus 4. And then over here, when I have c times x squared, I've got here that c is 3. So when x is 1, 3 times 1 squared is just obviously 3. So if I simplify this, I've got 7 equals 2a. Then minus 4 plus 3 is minus 1 overall. Add 1 to both sides. 8 equals 2a. Finally, dividing through by 2, I see that a must be equal to 4. And so therefore, we've worked out, as we needed, the values of the constants a, b, and c. In other words, I have that a is 4, b is minus 2, and c is equal to 3. So now that we're suitably warmed up, let's now proceed and go on to the main body of today's session, which is about this topic of parametric differentiation. So what is it, essentially? Well, sometimes x and y are related together by a third variable, often t. So like I say, it's often called this parameter and is given with the letter t. It can be something different, sometimes theta, for example. But let's have a look what this means. So if x and y are functions of a parameter t, then we can use a chain rule and say that dy by dt, y differentiated with respect to t, is dy by dx multiplied by dx by dt. That can then be rearranged so that dy by dx is just simply dy by dt divided by dx by dt. And so that is how we can get dy by dx in terms of t. So just what I've said here, just dividing through by dx over dt gives us this here. We can now use this result in practice and tackle some worked examples using it. So let's have a look now at worked example 1. So first of all, we need to find the gradient at the point 3, 3 on a curve given parametrically by these two equations involving x and y. So both are given in terms of t. So what I'm going to suggest we do first of all is to rewrite x in index form. So x equals 2t, and 1 over t I'm going to rewrite as t to the minus 1. That just makes it easier, in my opinion, to work out dx by dt. So therefore, differentiating x with respect to t, 2t becomes 2, t to the minus 1 comes to the front, so I got minus t, and we knock 1 off the power of minus 1 take away another 1, gives us minus 2. And from y being 3t squared, obviously we can see that dy by dt, that's very easy to differentiate, that just gives us 6t. So therefore, dy by dx, using the result we had before, is dy over dt divided by dx over dt. So dx over dt was 2 minus t to the minus 2, whereas dy by dt is simply 6t. So if we just plug this in now, we get 6t on top divided by 2 minus t to minus 2 on the bottom. Now we don't need to do anything else with this in terms of rearranging or simplifying, because all we need to do is actually just process the value of a gradient of a point 3, 3. So all we need to do now is use dy by dx and substitute in the correct value of t when x is 3. So when x is 3, for example, I could pick when y is 3, because obviously y is also 3, but here we have 3t squared. Remember, when we do the square root, we need to consider plus or minus. So by looking at the x equation here, there's no ambiguity. That's why I'm picking the x equation. So when x is 3, all we need to do here is just sub in x being 3, and then solve for what t is when x and y is 3. So we have 3 equals 2t plus 1 over t. Just summing in when x is 3. If we now multiply both sides of this equation by t, we next get that 3t equals 2t plus 1. Then if you take away 2t from both sides, therefore we know that t must equal 1 at this point where x is 3 and y is 3. So when x is equal to 1, so therefore dy by dx, which is going to give us the gradient at that point when x is equal to 3, that's just a way of saying the gradient when x is equal to 3. That's the same when x, so when x is equal to 3, that's the same as t being equal to 1. So here we just sub in t being equal to 1. So 6t then becomes 6 times 1, and then 2 minus t to the minus 2 becomes 2 minus 1 to the power minus 2. Now, if you want to do this on your calculator, in fact, I'll just do it with you now, why not? You'll get a value of 6, but I'll show you how to type this in. So press the fraction button, 6 times 1 on top, at the bottom, 2 minus 1 to the power of minus 2 gives us a value of 6. So the gradient of the point 3, 3 for this parametric curve, is 6. Let's now have a look at a second worked example. So this worked example, we're asked to find the equation of a normal this time at the point P, where theta is pi over 6 at that point P, to the curve with parametric equations x equals 3 sine theta and that y equals 5 cos theta. So what we need to do again here is to work out dx by dt and then of course dy by dt. So looking at x, first of all, if we differentiate x with respect to t, dx by dt, sine differentiates to cos, so 3 sine theta differentiates to 3 cos theta. And if y is 5 cos theta, then dy by dt, cosine differentiates to minus sine, so 5 cos theta becomes minus 5 sine theta. So then from these two, we can then work out dy over dx. So dy by dx is going to be dy by dt divided by dx over dt. So dy by dt was minus 5 sine theta, and then dx by dt we had was 3 cosine theta. So sine divided by cos is the same as tan, and minus 5 over 3 we can just put as minus 5 over 3 tan theta. So now we want to work out the equation of the normal. So when we now have theta equals pi over 6. So let's just think about when theta is equal to pi over 6. So when theta is pi over 6, dy by dx, which is going to be the equation of the tangent, sorry, the gradient of a tangent. You don't need to put it as a gradient of a tangent, I'm just putting this in for extra information. So minus 5 over 3 times tan theta, let's just type this in on the calculator, why not? So press the fraction button first of all, minus 5 over 3 tan theta, pi over 6, make sure in radians mode, so shift pi, divide by 6 or over 6, either or. We get minus 5 root 3 over 9. So therefore, we actually wanted the gradient of the normal. So gradient of the normal will be the negative reciprocal of the gradient of the tangent at that point. I'm going to show you now the reciprocal function on the calculator. So on the class whiz, if you've got a value here, you want to work out the reciprocal of that, all we need to do is press A and S for the answer previously stored, and then there is actually an x to the minus 1 button here, so that reciprocates it. But of course, remember, the tangent and the normal, one is the negative reciprocal of the other, not just the reciprocal. So we need to reciprocate it like we have done here, and then change the sign. So therefore, the gradient of the normal is positive 3 root 3 over 5. Just check that there. 3 root 3 over 5, yes. We also need to work out what x is and what y is when theta is pi over 6. So x is 3 sine pi over 6, which in older money is 3 sine 30. If you want to do that on your calculator, be my guest. You need to know that sine 30 or sine pi over 6 is a half. So 3 times a half is 3 over 2. And when theta is pi over 6, y, 5 cos theta, cos of pi over 6, or cos of 30 degrees, is root 3 over 2. So y is going to become 5 root 3 over 2. We can then use the general equation for any straight line from GCSE now. And that equation is, of course, the good old y equals mx plus c. So we want the gradient of a normal. Okay, so for this normal, we know the gradient of a normal is 3 root 3 over 5. So I know my m. I can now sub in a coordinate pair, which I know. So I know that when x is 3 over 2, the value of y that goes with that is 5 root 3 over 2. So I then just substitute in these values to work out the corresponding value of what the constant c must be. So y, 5 root 3 over 2, equals the gradient of the normal, which we worked out as 3 root 3 over 5 by doing the negative reciprocal of the gradient of a tangent. So 3 root 3 over 5 multiplied by the value of x we had, which is 3 over 2. So y gradient was this, the value of x, 3 over 2, plus c. We can now rearrange this to work out what c is. So if we just take this equation here, so I've got on one side 5 root 3 over 2, just 5 root 3 over 2 like we have here, and then to solve this I'd need to subtract from both sides 3 root 3 over 5 multiplied by 3 over 2. So I'm going to do that now. So take away from that 3 root 3 over 5 multiplied by 3 over 2. And that gives me that c has to be 8 root 3 over 5. So therefore, normal has to be y equals m 3 root 3 over 5 lots of x plus c, which is 8 root 3 over 5. And that is at least one valid equation of the normal to the curve when theta equals pi over 6. You could also write this in different ways, but I do think probably the easiest way of doing an equation of a straight line is still y equals mx plus c after all this time. Let's now have a look at the final worked example number 3. So this is actually taken from an exam paper, to be honest. So if you can do this, this is a good acid test. This is what you might be faced with the real thing in your actual exams. So we've got a diagram showing a sketch of a parametric equation, curve C, given parametrically in terms of x and y as follows. Here, first of all, we need to show that dy by dx is k root 3 tan 2t, where k is some constant to be determined. So let's begin by finding dx by dt and then dy by dt. And so x, we're told, is root 3 sine 2t. So starting off with this one, dx by dt is easy to do as long as you can remember how to differentiate sine. So dx by dt, sine differentiates to cos, but because here it's not just sine t, it's sine 2t, that 2, the constant comes to the front. And so we're going to have 2 root 3 instead, and then the sine turns to cos. So sine 2t becomes cos 2t when we differentiate it. So that's an expression for dx by dt. Now for y, to work out dy by dt, what I'm going to suggest we do is think of this as y equaling 4u squared. And we can now use the chain rule to differentiate y. So y equals 4u squared. I'm going to call u being cos t. So then dy by dt, using the chain rule, that's going to be dy by du multiplied by du by dt. So if just use this here. So dy by du, if y is 4u squared, differentiating y with respect to u gives us 8u. And then if u is cos t, du by dt, cos differentiates to negative sine. So we have 8u multiplied by minus sine t. And then substituting back in that u actually was cos t, we're then going to have, I'll just move it down here in fact, we're going to have minus 8 sine t, and u is of course cos t. Now what we can do here, because we want our dy by dx in the form tan of 2t, whereas here this is all in terms of just 1t, we need to use a double angle formula here. So if I just section out, instead of minus 8 and minus 4, I can now write in brackets 2 sine t cos t. And like I say, if we remember our double angle formulae, we know that 2 sine t cos t is the same as sine 2t. So we have minus 4 lots of sine 2t. And so, in other words, if y is 4 cos squared t, then dy by dt will give us minus 4 sine 2t. So now for part A, we've got the ingredients to actually work out what dy by dx is. So for part A, dy by dx is dy by dt divided by dx by dt. So dy by dt worked out from, dy by dt is minus 4 sine 2t. So you can write this here. Whereas we had from before that dx by dt was 2 root 3 cos 2t. So now we can see we've got sine 2t on the top and cos 2t on the bottom, so therefore we can section out tan 2t, which is exactly what we need. So in terms of this value at the front, minus 4 over 2 root 3, I think the best thing to do is just use a calculator to work out what this is in terms of being k root 3. So if I just ignore the sine 2t over cos 2t and back myself to know this is tan 2t, I can then just do minus 4 over 2 root 3 on the calculator, like I say. So, press the fraction button, press minus 4 on the top, toggle down, press 2 root 3, and then get minus 2 root 3 over 3. So I'm going to write this as minus 2/3 root 3. Like so. So that's what dy by dx is, where k is a constant to be found. So not that we're actually asked to state what the constant is, but k, if we wanted to say what it is, k is minus 2/3. Part B, we have to find an equation of a tangent to C of a point where t is pi over 3. So give your answer in the form y equals ax plus b, where a and b are constants. This is just another way of saying give it in terms of y equals mx plus c. Instead of m, we've got a, instead of b, we've got c. So for part B, let's just think about the information we can gather if we know that t equals pi over 3. So when t equals pi over 3, what do we have? Well, we can work out dy by dx for starters. So dy by dx is going to be minus 2 over 3 root 3 tan of 2t. So if t is pi over 3, 2t is going to be 2 pi over 3. So if we just bang this into our calculator and type it in very carefully, so we've got minus 2 over 3, toggle down, multiplied by root 3, multiplied again by tan, in brackets, 2 pi, in radians of course, over 3. Close brackets, press equals, we get 2. So therefore, the gradient of the tangent, where t equals pi over 3, the gradient is 2. We also need to work out what x is and what y is when t is pi over 3. So x is going to be root 3 sine of 2 pi over 3, which again we can work out fairly easily using the calculator. So if I just delete everything from here, leave the root 3 as it is, then if I just delete the sine, sorry, the tan to get sine, and it was of course root 3, made a bit of a hash of reconfiguring this, so root 3 sine 2 pi over 3, that gives us 3 over 2, and y is going to be 4 cos squared t, where t is pi over 3. So in terms of doing this on the calculator, we can just type in 4, where we do cos pi over 3 again. And times the same thing. We could do pi over 3 in brackets all squared. Doesn't really make any difference, to be fair. We get equals 1. And so then if we use good old y equals mx plus c, summing in what we have, we've worked out the gradient of the tangent is 2, because we know dy by dx is 2, so our m is 2. And we also know 2 points now. We know that when t is pi over 3, the coordinates of x is 3 over 2, and the coordinate of y is 1. So we can use this in terms of substituting in. So x is 3 over 2, and y is going to be 1. So if we just substitute these values in, so y we've got is equal to 1 equals m, which is 2, multiplied by the known coordinate of x, which is 3 over 2, plus some y-axis intercept c, which we can now work out. So 2, of course, was a gradient m, which we got was 2. So if we just rearrange this, expand and simplify, so 2 times 3 halves is obviously just 3, so 1 equals 3 plus c. So therefore c, taking 3 from both sides, c is 1 minus 3, which is minus 2. So therefore, the equation of a tangent to c has got the equation y equals mx, so 2x plus c. C is minus 2, so plus minus 2, in other words, just minus 2 like so. Then we're nearly home and dry, so we need to do part C now. So part C, we need to find a Cartesian equation of C. Notice it doesn't say find the Cartesian equation of C, just to find one Cartesian equation. So what I'm going to do here for part C, I'm going to rewrite down what x is and what y is, just so we're not hanging off the screen because I need to move down. So for part C, we have that x, scroll up, what was x? X is root 3 sine 2t. We have that y was 4 cos squared t. So now what we need to do is to eliminate t, so it's all in terms of just x and y. The thing to notice here is we've got sine in terms of 2t and then cos just in terms of t. So my suggestion would be to use the double angle formula here and split the sine 2t into sines and coses. So this is the same as root 3. Then sine 2t is the same as 2 sine t cos t. So now we have that, what we can do is actually think about trying to get y in here. So if we see y is 4 cos squared, and here we have no squared terms, what we could do is actually just square x. So x, 2 times root 3 sine t cos t. If I now square both bits, literally square them, being quite lazy about just drawing in a square instead of actually writing the word square, I have that x squared, 2 root 3 all squared. If you want to do this on a calculator, let's just do that. 2 root 3 equals, square it, you get 12. So x squared equals 12 sine squared cos squared t. And now what we can think about is what y is equal to. So y is equal to 4 cos squared t. And so what I can say here is that x squared, I can say this is equal to 3 sine squared t multiplied by 4 cos squared t. In other words, x squared equals 3 sine squared t. Now I'm going to change sine squared in terms of all cos squared. So cos squared t, well, sine squared is 1 minus cos squared. So if I just replace this with 1 minus cos squared t, and then 4 cos squared t is the same as y. So then we're nearly done. So then we've got x squared, and then 1 minus cos squared t. Well, what is this going to be? Well, cos squared t, if I just draw a line here, I can make cos squared the subject. Cos squared of t is just simply y divided by 4. Just dividing both sides of this thing here by 4. So then I have x squared equals 3 in brackets 1 minus cos squared t. So that's going to be 1 minus y over 4 multiplied by y. So now we can write this in a slightly neater form. So an equation could be x squared equals 3 times y, so 3y brackets 1 minus y over 4. That's just one form of the equation could be written in. There are multiple, but your answer needs to be in the same format as what I've got here. So that's an exam style question done. Hopefully you found that useful alongside worked examples 1 and 2. It's now over to you to try some of these questions on your own to gain some well-needed practice. So what I'm suggesting you do here is turn to your books, go to page 251 and try some of question 1. The question parts I've noted here, which is what I'd suggest to do. Your own teacher might recommend differently. Question 3, question 4, then question 6, all the way through to question 11. And by now you know the drill. Check your answers regularly. If you're unsure, ask a neighbour or me for help. And if you can't find me, either leave a comment on the video or please do send an email or see me after class or something like this. So thank you again for listening. Do take care of yourselves and I hope to see you all soon. Thank you very much once again from Mr. Bailey. Goodbye for now.